If you want to see attractive animated tutorials like this one, visit algopk.com. Now let's dive into arrays, one of the most important data structures in programming. What is an array? Imagine a row of boxes sitting right next to each other. Each box holds one value, and each box has a number starting from 0. That's an array. Look at the animation on your screen. You can see each element has an index below it and a memory address above it. Index 0, index 1, index 2, and so on. The special thing about arrays is contiguous memory. Contiguous means side by side with no gaps, just like houses on a street, one after another. Now, watch this carefully. This is why arrays are powerful. Every array has a base address where it starts in memory. When you ask for any element, the computer uses a simple formula. Address equals base address plus index times element size. Look at the animation. If base address is 1000H and you want index 3, the computer calculates 1000H plus 3 times 4 bytes. That gives 1000C. It jumps directly there, no searching, instant access. This is called O of 1, or constant time. Whether you have 10 elements or 10 million, accessing any element takes the same time. Now let's see access in action. Click the Access button and watch. You give an index, the computer calculates the address. It returns the value immediately. See how fast that was? That's the beauty of arrays, direct access to any element. Now, searching is different. Watch the linear search animation. If I ask you to find value 42, the computer doesn't know where it is. It must check index 0. Is it 42? No. Check index 1. Is it 42? No. Keep going until we find it or reach the end. This takes O of n time. In worst case, we check every element. The more elements, the longer it takes. Inserting elements is where arrays show their weakness. Watch carefully. To insert at index 2, we cannot just place the value there. Something is already there. So first, we shift elements. Index 2 moves to index 3. Index 3 moves to index 4, and so on. See the shifting animation? All those elements must move one position right. Then we place our new value in the empty spot. This is O of n because we might shift all elements. Deletion is similar. Watch the delete animation. When we remove an element, it leaves a gap. Arrays cannot have gaps, so we shift elements left to fill the hole. Index 3 moves to index 2. Index 4 moves to index 3. The array shrinks by 1. Again, O of n time because of shifting. Now, why use arrays? Use arrays when you need fast access by position. Use arrays when your data size is fixed or mostly fixed. Use arrays for collections of similar items like scores, prices, or coordinates. Don't use arrays when you insert or delete frequently in the middle. That's where linked lists are better. Quick warning about common errors. First, index out of bounds. If array has 5 elements, valid indices are 0 to 4. Accessing index 5 crashes your program. Second, forgetting zero-based indexing. First element is index 0, not index 1. Third, forgetting to shift when inserting or deleting. The animation shows you exactly what must happen. Real-world uses. Arrays are everywhere. Photos are 2D arrays of pixels. Videos are arrays of frames. Your playlist is an array of songs. Game inventories, spreadsheet data, sensor readings, all arrays. That's arrays explained simply. Practice the operations, watch the animations, build your understanding. Remember, for more attractive animated tutorials on data structures and algorithms, visit algopk.com.